In this demo, we're going to show you how App Firewall is able to provide very granular security within your data center. In this case, we're actually going to try to use App Firewall to secure a two-tier application, which is going to be WordPress in this case. In WordPress, we have a web server here, which is Ubuntu Linux with Apache and PHP. And we have an Ubuntu server installed with MySQL. This provides the database for WordPress. And just to simulate a compromised host within the same data center network, we have one more VM which is installed with Backtrack Linux. And if you know, Backtrack Linux is essentially a security audit tool which has a whole host of security tools which you can use to test and penetrate through services. Don't try this at home. So before we start, let's have a look at what kind of policies we have in place. Right now, we actually have a default allow any rule. Right, it allows traffic from everywhere to anywhere, and this is true at the Ethernet layer as well. So we also allow all kind of traffic across. So without further ado, let's start with the attacker's console. So assume that an attacker has compromised a machine within your data center. They've installed their tools, security tools, hacking tools, if you can call it that, and they are looking to compromise other VMs or other hosts within your data center to expand their influence, to maybe get access to additional information which they're not supposed to have. So this is console of an attacker, and just to show that we have an actual working application on the back, this is the page it's going to see. You can click around, have a look at the sample page, have a look at the first post. It's a hello world post. This is a fully functioning WordPress installation running on the two Ubuntu Linux machines. So I'd like to introduce as well a tool called EtherApe, which is a graphical monitoring tool to show connections which are occurring to and from this host, and as well as any kind of additional traffic which it receives. We'll come back to that because we're going to see how network connections are established when we do a port scan, and what the firewall actually does to prevent that. We have a graphical front end for NMAP. It's called ZenMap, but actual tool running behind is NMAP, which is really a network port scanner. And with this tool, we're actually going to identify both tiers of the application, both the web app and the database virtual machines, and we're going to put them through a fairly regular scan, right? And once we click on that, we're actually going to jump back to EtherApe to see how a port scan looks like when represented graphically. So let's start. Here's scan, and if you look at the back screen, right, we can see that EtherApe is pretty much going crazy. You can see that the compromised host is communicating with web app and the database servers, and the fact that you can see that as a circle which expands on both the database and web app virtual machines means also that there is a communication, there's traffic coming from these VMs back to the compromised host. That means these VMs are actually responding, these services are responding. So let's have a look at the result of our scan, and we found that actually we've discovered quite a few open ports, quite a few available services on each of the machines. On the web app machine, we found that SSH and HTTP is enabled. No surprise about HTTP because that's Apache running there, and we have PHP behind that. And on the Ubuntu SQL Server, well, we have MySQL running on port 3306. No surprise there as well. So this is, if you are coming from the attacker's point of view, you're going to see that pretty much this is a buffet of whatever you want to compromise. Right? A lot of open ports. You can try to break into each of these services. If you don't succeed, you can try the next one. Right? We want to make sure that the attack surface is actually much smaller than this. So how do we do that? Let's go back to Visual Manager and try to lock things down using our App Firewall. How we do that is first by creating zones, security zones within our data center. First of all, we can start with in this case, the database zone. And we'll be sure to put the database virtual machine to that zone. That's one. And we'll create another zone, call it the web zone. And we'll put in the web app VM in here. So that's two groups, two zones. Now, essentially these are just groupings, right? They're logical groupings. We can add more VMs in as we require them. But let's see how we can use these groupings, these zones, to enforce policies. So first thing we want to do is to make sure that we no longer allow any policy. We just want to have a deny all policy. And then we start setting in the policies which we actually do want to allow. So in this case, we want to have a policy which allows web to DB communication. Right. So for source and destination, we'll start by having both of these zones here. So both of these zones can be sources, and both of them can also be, let's move that a bit, both of them can also be destinations. And because we somewhat trust both of them, we'll keep this fairly open. And of course, we want to be sure that we allow access to the HTTP service as well on the web zone, because that's where we're hosting our web services. So that's one more. We're going to allow anyone to access only the web zone, and very specifically the HTTP service, which is web service. Scroll down, should be somewhere around here. Yeah. Add that in, and we're good to go. Okay, so we've got our zone set up and we've got our policy set up. We'll publish that. Now we want to show that everything still works, right? So we're going to come back to the attacker's console. Now imagine we're running that same attack again. First of all, we come back to the browser. We want to be sure that everything is functioning as it should. We haven't broken anything. So let's click around. Yep, we can move to the sample page. We've gone to hello world. Host again. Okay, so it looks like it works. Yeah, so it shows that compromised host has accessed web app. Well and good. So let's try running that same port scan that we did from earlier on and see what else we can, what changes there have been. Note here that we have SSH service open on both VMs. We have HTTP on the web app VM, and we have MySQL on the database VM. So let's try running a new scan and see what results we get from that. So as you can see, we're seeing the compromised host send a lot of traffic to the web hosts and the database hosts, but we're not seeing a lot of return from the database or web hosts, right? Because we've already set in a filter, so a lot of traffic which is actually being sent out by the compromised host isn't really reaching the web or the database VMs. It's been filtered along the way. So let's see what NMAP tells us this time. You can see that there's significant changes here. On the web VM, we used to have both SSH and HTTP services open, but now we only have port 80, which is only HTTP. And on the database VM, we don't see any open ports at all. We know for sure that behind the firewall there's HTTP and there's MySQL and there's SSH behind there, but that's not showing up on NMAP when an intruder does a port scan, right? But we do know that this VM actually exists because we can get a MAC address, right? Because from the ARP resolution process, we're actually able to know that this VM actually still exists. What if we wanted to tighten this down even further? And we can. We can essentially make this VM look invisible completely to the malicious intruder. So let's go back to Visual Manager again. And now we start enforcing policies at the Ethernet level. So we go back and set in a deny all rule right at the end of the list. And we start adding in our own rules. Same as before. We'll allow the web and DB VMs to talk to each other. So for a source, we have destination. Add those in, and we're good to go. or we need to add one more. Right? We need to be sure that we allow traffic from anywhere going to the web zone is actually allowed. Don't want to break our web connectivity. I think that didn't take. Let's try that again. We want to create a return. So from web zone going out anywhere, we're going to allow that. So let's call it rule 1 for now. This is for the return. And we'll be sure that it's all allowed here. So that's great. Let's publish the change. Let's go back to the attacker's console again. And we want to check and make sure that our application hasn't broken from any of the changes that we made. So let's go back. Let's go back to the initial site. Web app. Cool. You see the application is still online. Let's have a look at the sample page. It's still there. Hello world still works. Okay, so we know the application is still in good shape. Look at EtherApe, we know that we're still connecting directly to the web application here. So let's run our NMAP scan again. Same scan, same targets, and we run it. And we go back to EtherApe. And this time you see that it's very interesting that the database VM doesn't even show up. We see the compromised host trying to send a lot of traffic at the web VM, but there's no response from the web VM, and as I said, right, the database VM doesn't even show up at all. It's non-existent from the point of view of the malicious intruder. And that's very interesting because if you remember at the start, I mentioned that all of these VMs, they are within the same network, right? So if we look at NMAP, we see that we've locked it down further. We still have the web VM, and we still have the port 80 web service still around, but for all purposes, to the malicious intruder, it appears that the database VM no longer exists. It seems to be down, so it's completely cut off from a compromised host or from any attacker on the compromised host, right? So as I mentioned earlier, this is how we can really use VCNS App Firewall to provide very, very granular security at the data center level, regardless of whether these VMs are sitting on the same network or not. And with App Firewall, the benefit becomes that without even using a perimeter firewall, you can even provide that in-depth security within the same layer 2 network itself, right? So that's all I have for the App Firewall demo. Thank you.